Welcome to conceptual classes on organic chemistry. Today's class is class number 2 and my topic was hydrocarbon. It is from higher secondary first year science. So in my last class I mentioned about the preparation of alkane. Last topic was preparation of alkane and I did up to Cook's electrolytic method. Now, before starting this, I have just forgotten to mention two important catalysts. I had given a list of catalyst and reagent and also a list of some important compounds and other things. So these two important catalysts are, please add up. One is Lindlar catalyst and this is palladium over barium sulfate, or you can write this, and another is sodium. These two catalysts are very important in liquid ammonia. And another is Bayer's reagent. You minutely follow, and this is aqueous alkaline. Sometimes it is written cold, KMNO4. And 2 years ago that question was asked in NEET. So about Lindlar catalyst, you will get it in details a bit later. And one thing, just you keep it in your mind, Lindlar catalyst, and one of the important application I am just mentioning here is, say you will get the details of it a bit later. Say if you use Lindlar, there is hydrogen will be added, and addition of hydrogen will be in this way. You may not have the idea of cis and trans, that I will explain in a separate topic, stereoisomers, conformational isomers, cis and trans isomers. You will get it. It is inside your syllabus. So for time being, you keep it in your mind, it is cis. And one of the important speciality of this Lindlar catalyst is, first is the addition is cis. Priority groups, you will get it later on, priority groups remain in the same side. It is cis. And second speciality, double bond is restricted to single bond. It doesn't go further on adding hydrogen to give alkane, because in Sanderson reactions you got, if there is alkyne triple bond, it first react with H2, it becomes double bond. Further automatically it gets added to double bond, gives you single bond. The process was continuous. It is unstopped. Am I right? But here the speciality of this catalyst is that this reaction, the reaction stops from triple bond to double bond. It doesn't further continue up to alkane. This is one of the important speciality of Lindlar catalyst. Number second one is again important. You see, these are very important things. You should keep it in your mind, because these are very often asked in entrance exam or in class exam. And if you do not use Lindlar, if use sodium in liquid ammonia, your answer will be again in this way. So for time being, you keep it in your mind, it is strands. Again, you see, in earlier cases it was cis, and in this case it is strands, and that is a special type of reaction. It is called Birk reduction. Birk reduction. Please try to keep it in your mind. These are very important reagent and name reaction. Birk reduction. Am I right? So next one is Bayer's reagent. Bayer's reagent is also very important, and it is used for oxidation process. Just you keep the name in your mind. So let me come to my point, that is preparation. I was dealt with preparation. Now what is the preparation of the third part of the preparation? Decarboxylation. Decarboxylation. So at the very beginning I told you what is decarboxylation. D means loss, carboxylation means carboxylic acid group. That group will be lost in the form of carbon dioxide or sodium carbonate, anything. Decarboxylation, carboxylic acid will be lost out. So in decarboxylation, there was a question in 2023. So minutely follow. Each and every question is from your content of chapter. So minutely follow me. You will find each and every question's answer. Decarboxylation. So first of all, one step back I am going. If it is acetic acid, if you react with sodium, that acetic acid become sodium acetate. Am I right? I am giving this one, you need not give sodium acetate. So this is sodium acetate. Uh, the reaction occurs in this way, it is replaced by this one. In second year carboxylic chapter I have done it. If you want to know much more than this, you go to the second year chapters, organic chapters. I have given a series of questions, chapter wise explanation from class 1 to 11 up till now. And if you want to make your concept sound, you can see it, you can very easily understand each and every one. So this is sodium ethanoate, you can date it sodium ethanoate or salt of carboxylic acid, sodium ethanoate. And this is, so if you recall, in the chapters I have uh, grouped all the important name of the compounds which are being used in the chapters, and I have given the name of this one is pseudolime. That's why beforehand I mentioned the name pseudolime. It is very important reaction, very important reaction. So here what's happened, very simple thing, and you keep it in your mind. Only one hydrogen is added in this part. So what is the answer? Answer is alkane. We will not be much more concentrated upon this one. Will be focused on this because our main aim is to prepare alkane. Am I right? We are dealing with alkane, so we have got alkane. So I am not telling the mechanism of this reaction. It is not out of your scope. So till you just keep it in your mind the trick, just one hydrogen is added in the reaction. In the question in NEET 2023, it is asked what's when sodium acetate is made to react with calcium in presence of sodium hydroxide, a compound is formed. What is the molecular weight of that compound if it is twice? Answer was 32. Anyway, 12 and 4 16, and double of this is 32. There was a lot of options. Am I right? This was the question. So I am again adding one thing. If I take, say, in phenol chapter, last day I gave phenol chapter for second year. If I use this one, so learn You, the first beginner of higher secondary first year, or those who are the aspirant of entrance exam, you can know that I have already used that compound reagent CaO and sodium hydroxide. This is soda lime, and when that reacts with sodium salt of something, maybe alkyl, maybe aryl, what happened? What trick I told you? I told you that you just add hydrogen here. Am I right? So blindly you write the answer. You don't touch anything else. OH remain OH, and in this place there is a one hydrogen. Hydrogen is introduced in the chapter, no, in the structure. No need to write anything. Your answer is simple phenol. Am I right? So keep it in your mind. Whenever you get COOCONA and CaO sodium hydroxide, you will get just hydrogen is added to that part. And important thing is that, and this reaction or this type of reaction is called decarboxylation, and it was given by Duma, and hence this process is called Duma process. Very beginning I gave you the name reaction Duma, is not it? So you, many of you may not know the reaction name of the reaction. It is Duma process. Am I right? So this is all about the third process of preparation of alkane. Now, what is the fourth process? Fourth process is Franklin reaction. This is very simple and very easy. That's why I am giving it. CH3 say Cl plus zinc CH3 Cl. You use ether. Answer is CH3 zinc chloride. Am I right? There is some similarity of this reaction with Wood's reaction. You just see the Wood's reaction. In Wood's reactions we used dry ether in and sodium. Just here Franklin used zinc. So there is some similarity of Wood's reaction and Franklin reaction. Next one is Clemenson reaction, and this is very important reaction, and a lot of question you get from second year aldehyde and ketone chapter. So beforehand you learn, you will find it very easy. You see, minutely follow CH3 C double bond O H plus the important thing is the reagent. When CO group is there and when you use zinc, mercury and concentrated hydrochloric acid, instantly you recall it is nothing but Clemenson reaction. And what's happened in Clemenson reaction? Uh, you may know the name. It is ethanol. CHO means L. In IPC name it is L. CHO means aldehyde. Aldehyde means L. CH3CHO means ethanol. Ethanol. And this is nascent hydrogen. Later on I will explain in inorganic chapter what is nascent hydrogen, because class will be lengthy. What happened here? One shortcut is there. First of all, you know the shortcut. What is this shortcut? Simply you do CH3 You see, CO becomes CH2. H remains as H. Are you not getting alkene? CH3, CH3. Is it not ethane? It is ethane. So from aldehyde to ethane, it was Clemenson who made a reduction. Actually, that reaction is Clemenson reduction. Aldehyde can be reduced to that one. So important reagent is, very often reagent is given, you are asked to name the reactions, and sometimes you are asked what is the name of the reaction. Lots of questions are being asked. You just whatever you learn it exactly what is written. Am I right? So at this point I want to mention one thing. So when I use the term reduction, for lifelong you keep it in your mind. What is reduction? In organic, reduction is addition of hydrogen, and oxidation is oxidation is removal of hydrogen. Just you follow, minutely follow, you will never find organic chemistry tough. It will be very easy for you if you follow this. Say CH3, C double bond O and H. That was our reaction, and I used 4 hydrogen. Am I right? I used 4 hydrogen, 4 nascent hydrogen. Okay, so reduction. Reduction, what does reduction means? Reduction means addition of hydrogen. How many hydrogen? 4 hydrogen. How will I add this? Let me show it very slowly. I am showing, just to follow. You yourself will be expert on converting addition, oxidation and reduction yourself. CH3, C O H H H. So you see the style of addition of hydrogen. One hydrogen is added to oxygen, and other hydrogen is added to that carbon. So addition is always carbon and that oxygen. So we have got this. Am I right? So this is not mechanism. This is the way, our trick I am showing how we have got the result. This is addition. This is addition of hydrogen. Reduction means addition of hydrogen. Now we have added 2 hydrogen, 1 hydrogen here and other hydrogen here, 2 hydrogen left. So now how will I add this another 2 hydrogen? You see, H H. Minutely follow you yourself, because all information cannot be kept in your mind if you do not know the rule. So what is the rule? You see, simple way. I have added 1 hydrogen here. I have added 1 hydrogen here. So what happens here is CH3, C O, that total part give you water. It goes out. Am I right? So what parts is in your hand? The answer is CH3. H is earlier, that H is this, and this H is this. Have you not got CH3, CH3? It is trick, not mechanism. So that this is how you should keep it in your mind. Reduction is like this. So next one is Wolff-Kishner. Wolff-Kishner reaction, or again it is reduction. Wolff-Kishner reaction, again it is in second year. You will get again in second year. Say CH3, C double bond O, CH3, but here reagent is changed. sodium NH2. You can use glycol or C6H5ONa, either glycol or C6H5ONa, anything. So it is hydrazine. It is hydrazine. 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 Am I right? Your answer you will find again. It is tough to. Like, I am not showing you the mechanism. The way, the trick what earlier is nothing but change of this CH3, CH2, CH3. Just to see the beauty of chemistry, CO group has changed to CH2. That you have got meet it propane. So it is very important. These two are very important: reduction reaction and name reactions, Clemenson reductions and Ulf-Kishner reductions. So also it is an important process for preparation of alkane. Alkane. Next one, probability 6, with Grignard reagent. With Grignard reagent, Grignard, Grignard reagent. So before reaction, let me tell something about Grignard reagent. R is alkyl, MgCl. This is organic part. This is organic and this is inorganic. So this compound is organometallic. Metal means organic. Organometallic. It is metal. Organometallic compound. And one of the speciality of this compound, huge things are to be explained here. I am not explaining all. Just for time being, you just one thing keep it in your mind, that this is minus and this is plus. Alkyl part means in alkyl CH3, it may be CH3, it may be CH3, CH2, maybe alkyl. So where there is carbon, carbon will be negative and magnesium will be positive. It is uh, ampolang, ampolang, reversality of polarity. No need to keep all these things in your mind. You just keep these things. Whenever you write Grignard reagent, this is Grignard reagent, you yourself can write. I am giving one example of Grignard reagent. Say it is methyl group, one is magnesium, other is chlorine, other is bromine, anything. Am I right? So methyl magnesium chloride. It is an example of organometallic compounds where there is metal and organic compound and chlorine is there, and that will be plus and that will be minus. Very often this will come in need in second year. In second year, lots of question will be there with organometallic compound. If you do not know the charge separation in this one, you will literally impossible for you to write all the questions or keep all these questions of organic metallic compound in your mind. So what's happened here is, I need to prepare alkane. So let me take an organic compound CH3, sorry, organometallic compound. Say this is organometallic compound, and I am writing water. What's happened when methyl magnesium bromide is treated with water? Answer. This is minus and this is plus. Am I right? This is minus and this is plus in ionic form. So sorry, this is minus and this is plus. So that minus will come to this one, plus will come to this one, and minus will come to this one. So what we get here is methane plus MgOH. Very simple, very simple. We are getting alkane MgOH. Lots of reactions of Grignard reagent you will come across a bit later on. Just I have shown you a very simple one, Grignard reagent with this. Next one, physical behavior. physical behavior. Very important information is, if carbon chain is carbon 1 to carbon 4, these compounds are gaseous, and from 5 to carbon 17, if carbon chain length carbon 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 length 17, it is liquid, and if it is more than 17, means carbon 18 onward, that will be solid. And there is one exception, neopentane. Neopentane is gas. Here it also liquid. Neopentane is gas. What is neopentane? That is CH3, 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 CH3. Their carbon number is 1, 2, 3, 4, 5. Am I right? That should be liquid, but there is exception. It is gas. So you keep it in your mind. So we have seen this one. So now let me tell something, very little about melting and boiling point. Melting point and boiling point. This actually is directly proportional to molecular mass of alkane. These are not soluble in alcohol. These are not soluble. Alkanes are generally not soluble in water, inorganic solvent. These are soluble in organic solvent like benzene, carbon tetrachloride, etc. And these are soluble in alcohols also. Melting and boiling point. Melting boiling point is directly proportional to mass and inversely proportional to branching. What does it mean? Branching means if it is open chain like carbon 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 carbon, a lots molecular mass increases, CH3 CH2 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 increases, more the molecular molecular mass, more will be melting and boiling point. Am I right? Because there will be more van der Waals forces. Van der Waals forces. More the van der Waals forces, more will be molecular mass. In inorganic, you will get the term van der Waals. Am I right? So what does branching mean? Now, if it is open chain, the surface area is more. More the surface area, more will be the amount of energy will be required to melt it or boil it. Am I right? So if I just make it in this way, 1, 2, 3, 4, 5. If I arrange this 5 carbon lines, so surface area reduced. So smaller the surface area, lower is the energy to boil it or melt it. Am I right? So if branching increases, boiling or melting point decreases. In a very short, I am explaining these things. Am I right? So one of the another important thing is this: if even number hydrocarbon, even number alkane or hydrocarbon, melting point is more than odd numbered. Say it is 1, 2, 3, 4, 5, 6. Am I right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So melting point on this one will be increased. 1, 2, 3, 4, 5, 6, 7, 6. That is hexane and that is pentane. This will be. This is due to symmetry. If it is even, then symmetry exists. If symmetry exists, they are very easily fit symmetrically in the crystal. So huge amount of energy is required to melt. So due to the symmetry of even number of carbon in the hydrocarbon, the melting point is more, and it doesn't fit exactly in the crystal due to unsymmetry. Therefore, odd number of carbon hydrocarbon hydrocarbon having odd numbers has less melting point due to lack of symmetry in it. So important thing, I am now coming on reactivity or reactions of alkane. So far we have explained the how alkanes are prepared. and what are their, in short, what are their physical behavior. Now our main aim is to find out the to see what type of reactions they undergo. Am I right? So Arfa, এখন তেনা দে রে তেনা তেনা দে রুষে দে খালা হয়ে গেছে বুট। আরে হ্যাঁ দেওরে বাদেও খালা হয়ে গেছে বুট। So first type of reaction is substitution reaction. Since alkane are double bonded compounds, so you can't add anything up, because if you want to add something, its valence will be more than 4. You can't do so. So what you can do here is you remove one or two substituent, maybe methyl, maybe hydrogen, anything. You remove one or two, and in place you introduce another one. That is called substitution reaction. So very important substitution reaction in your book, it is given when ultraviolet light is given and methane in presence of chlorine. Answer is so on, means later on CH3 again will, one hydrogen is removed, you are getting this Cl, another hydrogen will be removed from this one, another chlorine will come, then CH2Cl, again from here another hydrogen will be replaced by another chlorine. You will get one hydrogen will be less, one chlorine will be more. Am I right? Next, one hydrogen, this one left out hydrogen will be removed and one chlorine will be added. That is, this reaction will continue until one hydrogen, no hydrogen is left out. So this is substitution reaction, and this reaction mechanism is important. It is free radical mechanism. Free radical mechanism. So what is free radical? Free radical are the species which are generated for when the bond is covalent bond is homolytically fusion occurs. When bond is broken homolytically, that is, say A bond with A, if bond is broken here, that is called homolytic bond fission. One electron here, one electron here, that is called odd electron species. These are free radicals. These radicals are very reactives. Am I right? So homolytic bond fission occurs here. So here free radical reaction mechanism, I will first do what? In the first step, it is called initiation. First, do one thing you do. Free radical is initiated. You can write initiation. Chlorine that breaks homolytically. Chlorine. Am I right? So you have got free radical. Now this step is called initiation. Second step is called propagation. Means that free radical will attack the alkane and reaction will proceed, propagate. It will progress, it will continue until and unless hydrogen is left. Am I right? And that step is called propagation. So I am showing you one or two steps how propagation occurs. Say this is methane. I can write methane here in this way. One free radical is produced, this Cl free radical. Am I right? And how it occurs? It is half arrow. This is half arrow. This two electron will give you a one bond, one line, one bond. Am I right? So what we get here? is CH H free radical HCl. HCl. These two bond will give one bond with Cl. So HCl. Now this is free radical. CH3 free radical. You can write CH3 free radical. So next step is that HCH free radical reacts again with chlorine molecule. Am I right? So what's happened here? That is half arrow. That is half arrow. Again, this and these two will make a bond, and that bond will be with that compound. Am I right? So you are getting H, CH, H, and new bond is this two dot gives you chlorine. So methyl chloride CH3Cl. Am I right? So next step, you see, this is the beauty of chemistry. Then you see that one H, C, H, and you make this chlorine down and take this hydrogen or any one hydrogen in this direction. Am I right? So I have written it this way. So free radical left, here free radical left. Once it is free radical, then with molecule, then again with free radical, then with molecule, then with free radical, then with molecule. Am I right? So first free radical, then molecule, again with free radical, already prepared in the reaction. Am I right? What you get here is H carbon, H Cl, and this two makes a bond with this. Sorry, this bond makes bond with HCl. Am I right? So what's happened in the next step? In the next step, HC, you take this H here or no? Okay, no need. There is already free radical. This is free radical plus. Am I right? Free radical, then with molecule. You will get radical left. So you see, in first case there was one hydrogen replaced one chlorine replacing one hydrogen, and in second stage we are getting another hydrogen is being replaced by another chlorine. In this way all the hydrogen will be replaced, so on, so on. Am I right? This is propagation step. Now how the reaction will finish, that is called termination. The finishing of reaction is called termination. So in the reaction mixture you have got, there is methyl free radical, this free radical, CH Cl2 free radical, like this you got a lot of free radicals. Am I right? So what's happened now, these two chlorine can to give you the stop of this reaction, chlorine or methyl free radical can combine together to give you ethane, or methyl free radical can combine with chloride, gives you methyl chloride. The mechanism very brilliantly shows you there is a, in the reaction mixture there are some ethane. So in the question they may ask why in the preparation of in the reaction of free radical reactions of alkane. It is free radical substitution reactions of methane with chlorine in UV light. Few amount of alkane is ethene is there. Answer, this is the reason. Am I right? In the termination step, this occurs. So this is all about substitution reaction. These are very important. You minutely follow. These are not hard. All things you want to learn, you should keep it in your mind. Next reaction is combustion. Combustion means to burn something in presence of air, means oxygen, and it is oxidation also. This reaction is called oxidation. So what is the general formula of alkane is, that was general formula of alkane, and I am showing you what's happen if combustion is made. Say it is carbon 1, carbon 1, n number 1, so 1 here 1 4, it is methane. If you place n1 plus n1 3 4 2, 4 divided by 2 or 2, n1 nothing, n1 1 2 twice water. So this is how we see when combustion means in presence of oxygen it is burned, we get carbon dioxide and water with production of huge amount of energy, hence hydrocarbons are used as fuel. Merit. Now that combustion, it is complete combustion, maybe incomplete, incomplete combustion, incomplete combustion. So what's happened? Combustion is incomplete. Incomplete means insufficient of hydrogen if the reaction is made. So how will you keep it in your mind? Just you see, you remove one hydrogen, you write the left side same, I am not balancing the reaction, am I right? And right side, when there was complete combustion carbon dioxide, you remove one hydrogen. Okay, your answer will be, you balance yourself, answer will be this. Another incomplete combustion is that you remove another carbon. This is called carbon black. Carbon black. So this is incomplete combustion. So complete combustion, oxidation. Incomplete combustion, you are getting one hydrogen less from carbon dioxide, carbon monoxide. Again another hydrogen less, carbon. Now controlled combustion. Controlled combustion. Controlled combustion, actually it takes place in presence of some amount of catalyst, and you will get methanol. You will get methanol. It is 5, I think 528, 5 copper, 528 Kelvin methanol. Again another reaction is CH4. If you make controlled combustion, molybdenum oxide heat, you will get HCHO. It is methanol or formaldehyde. Formaldehyde. Common name is formaldehyde methanol. Methanol CHO. Meth L. Again, very interesting part of oxidation reaction is methane does not easily undergo oxidation reaction. Does not easily undergo oxidation reaction. It is very tough to make it oxidized. Now, if I do one thing and that reaction is asked in your exam, if I replace all hydrogen, 3 hydrogen by CH3, CH3, CH3 means it is 3 degree hydrogen. In this case, if you use KMnO4, answer will be just there will be one O. CH3, C, CH3, CH3, OH. Just there will be O. So this name is, you can name yourself 1, 2, 3, 2 methyl propane 2 ol, 2 methyl propane 2 ol. Mind that alkane easily doesn't undergo oxidation. If there is 3 degree hydrogen, it undergoes oxidation to give you alcohol. So this is all about combustion or oxidation part. Next reaction is isomerization. Generally occurs in presence of anhydride aluminum chloride and HCl. And I am showing you one example: CH3, CH2, CH2, CH. It is N-butane. It is N-butane, and if I give the reagent anhydride aluminum chloride in HCl, answer is CH3, CH, CH3, CH3. It is N-butane. It is 2-methyl propane. Am I right? Only isomers. Do you know what is isomers? Isomers are the compound having same number of atoms, but structurally they are different, and due to the difference in structure, they have different melting and boiling point and other physical behaviors or reactivity. Am I right? Number of carbon, number of hydrogen, everything is same, that it is arranged. Mind that when in the question, in exam, if the question is given in this way, these reagents are given, you will try to introduce this reagent in the reactant. No, whenever aluminum chloride is there, be care, there will be rearrangement. Nothing will be used up in this reaction. So this is simple example of isomerization reaction. Next one is aromatization. Means aliphatic will become aromatic compound. Say CH3, CH2, 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 any one reagent, either this at this temperature, answer will be an aromatic benzene. So you see 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Actually, it is sometimes written in this way. Sometimes in your book it is written in this way. If you write in this way also it is okay. 1, 2, 3, 4, 5, 6. Use that reagent which I have already shown, that is benzene. Now you see, if you increase one hydrogen more, your answer will be this. Means hexane and hexane and heptane and heptane, you are getting toluene. You are getting toluene. How? Because here your structure is like this. 1, 2, 3, 4, 5, 6, 7. Use the same reagent, you are getting that bond give means it is methyl. You can give in this methyl. You can write in this way. You know how to write this structure. You have learnt. Am I right? This is aromatization. Next one is pyrolysis. I have used the term at the beginning of the reaction. Py pyro, py ro, pyrolysis. Pyrolysis means breaking of larger molecule. Am I right? 40 at high temperature about this you give. Uh, Actually, a lots of products shown, a lots of smaller units you will get. I have shown you simple one. Maybe alkane will be there. Uh, uh, Alkene is there. Am I right? C2H12. So this is pyrolysis. Simple. Bigger molecule of higher molecule, longer molecule of bigger molecule of higher molecular weights breaks into smaller units of lighter molecular mass weight under temperature is called pyrolysis. Very simple. Nothing is hard in pyrolysis process. At the last of this class, one of the important thing, what you recall, I am showing, and with this I will come to an end of this class for today. Uh, just you see, I am showing the beauty of chemistry. What you have learned, you just utilize these things in your mind. One thing, if there is alkyl halide, alkyl RX, and if you use potassium hydroxide or sodium hydroxide aqueous, mind that from today onward, if there is water aqueous, then that bond is replaced. It is substitution. It is called substitution. Am I right? And if this alkyl halide is there, if you use potassium hydroxide, not water, alcohol, mind that you will get alkene. That depends upon R. Am I right? You will get alkene. Just to keep it in your mind, alkene means a double bonded compound. Am I right? Uh, if you are confused, I am showing you how you will get alkene. No, the class will be lengthy one. So you will get alkane. So let me take one example. CH3, CH2. Is it ethane? This is ethane. You can't easily make it reactive, very less reactive. Let us use chlorine, CH3, CHCl. Let us use sodium hydroxide, potassium hydroxide, any hydroxide. Just now I have told that part will be replaced ethanol, you make oxidation, you make further oxidation, you make to react with sodium. I will explain. You use, everything is known to you. You are getting methane. So interesting facts, what I am explaining at the last of the class is see, chlorination. I have just replaced substitution reactions is chloride and sodium hydroxide. Just I have told you, when it is in aqueous position, it will be alcohol. Now on this, when oxidation is there, I told you a bit earlier, oxidation means removal of hydrogen. I am not writing this part, I am writing this part. You see, just follow. You keep it in your mind for lifelong, it will be come in neat. Am I right? That part is this. So if oxidation is removal of hydrogen, reduction is addition of hydrogen. So two hydrogen will be removed. One is from O, other is from C. So what you get is CHO. If you find it complicated now, for those who are beginners, you just keep it in your mind. On oxidation, CH2 OH on oxidation become CHO, on oxidation becomes COOH. Shortcut, simple shortcut. You keep it in your mind. And the reason I have shown you. Then if oxidation means removal of hydrogen, I have removed hydrogen, that becomes CHO, and again further oxidation, CHO becomes COOH. And a bit earlier, when decarboxylation, I discussed about decarboxylation reactions, I have shown you that when acetic acid is made to react with sodium, that hydrogen is replaced. Am I right? Here one hydrogen is replaced. Am I right? That hydrogen is replaced by chlorine, and here that chlorine is replaced by substitution reaction by OH. Here oxidation, this process or this, you are getting CHO, again further oxidation, that CHO becomes COOH. When you are making reaction, that decarboxylation reaction, I have shown you Duma process, that hydrogen is replaced, by sodium. And this is interesting, again Duma process, sodium ethanoate made to react with soda lime. It is soda lime. I told you that the important compounds I mentioned, this will come in need while I will discuss the chapter. Again, when soda lime is there, only one hydrogen is added. Hope you have followed the class minutely, and please go on alone in off time with the classes. And if you find the class more interesting, you don't forget to share, and also subscribe it to make others to know about organic chemistry. Thanks a lot.